So my name is Matt Hamilton. I'm a developer advocate at Protocol Labs, and we're going to talk about InterPlanetary Consensus, IPC. So you've heard these terms a few times today. Right at the start, in the intro, I asked people to put their hand up who had heard of IPC or InterPlanetary Consensus. And not many people had. And so, like I said, that's a good thing for the moment, because it means that there's plenty to learn here. In this talk, I'm going to be going into a bit more detail. You heard from Molly earlier on talking about scaling Filecoin's storage, and she touched on IPC as well. I'm going to go into a bit more detail, and then later on at 3:45, I've got a workshop in which we'll do a hands-on demo and deploy a smart contract to IPC, and possibly also spin up your own subnet. Those terms will make some more sense as we go on. So, what is IPC? IPC is a scalability technology that unlocks planetary scale performance for Web3. So you heard from Juan earlier talking about the sort of grand scheme and vision of Filecoin and Protocol Labs and the various technologies in this ecosystem. And we're looking to scale much further than existing blockchains. So we want to do that, and hopefully whilst delivering a very good developer experience as well on top of that. And the idea is to try and reach those same kind of limits, those same kind of scalability parameters and metrics that the sort of Web 2 ecosystem is at the moment. You know, Web 3 and blockchains are so far at the moment much further behind Web 2, and we're looking to catch up to that and get to that same kind of level. So things have been scaling. Going back to 2014, we had IPFS come out. And IPFS, we then had libp2p. libp2p has already been talked about as well as an underlying technology behind a lot of blockchains. I think it's about 11 different blockchains now, something like that, that is being used underneath the hood to allow the interconnection between the different nodes. And then we have Filecoin. You know, Filecoin, in terms of the amount of storage, we've heard about that. In terms of the amount of data storage, it truly is phenomenal in that side. But there are some problems. There's some problems with blockchains at the moment. So scaling to meet demand is very difficult. Scaling to meet the Web 2 use cases is very difficult. They're often monolithic. You don't have composability. You don't have the ability to take individual parts or possibly replace those parts as you see fit to build the applications you require. So often you have to sort of take it all or nothing and pick a particular blockchain specific to what you want to do. And in a lot of cases, there's you know, limited programmability on some of these. Obviously, we have smart contracts, but then, like we said, taking it further, and as Juan was talking about, not just getting onto smart contracts, but looking at intelligent contracts, looking at the next sort of stage of AI, we need to be looking at much more flexible blockchains to get to that stage. So within Protocol Labs, we've had a sort of an evolution. We had the original R&D around Filecoin and the original consensus mechanism on that. We then formed Consensus Labs, and Consensus Labs was an R&D house within Protocol Labs that was looking at different consensus models. And we also had FVM, the Filecoin virtual machine, that also came out of an R&D project. And we're now looking to actually productionize IPC that's come out of the Consensus Lab work. Now, I'm representing a bunch of my colleagues within Consensus Lab that have been doing all of this work. I get to stand up here and showcase all of the great stuff that they have done, and also pinch a lot of their slides from previous talks as well. So a lot of this is down to them and has come from them. So if we take a step back and look at the kind of the bigger picture of scalability, a lot of it is constrained by sheer physics, right? The speed at which you can transmit data over space, at the speed of light, gives you a certain bound by which you can transmit data. So what if we can actually break a blockchain up and have it represented not just as one monolithic thing, but as a number of subnets? And each one of those subnets could in turn be its own blockchain with its own consensus mechanism. So you could have one that is within a data center working at data center speeds. You could have one regional working within regional speeds, and kind of scale up from there. right? So that is the kind of idea behind that, and there's lots of reasons why you want to kind of go down this route with scalability. Like I said, you have an upper bound, a lower bound of the speed by which you can go based upon the geographic sort of nature of a network. But also you want to have things like application-specific networks as well, relating to specific applications or specific features, things like privacy or encryption, fully homomorphic encryption networks, zero-knowledge networks, that kind of thing. So this is where we ended up with IPC. This is the kind of goals of IPC. So we wanted an infinitely scalable network. We've ended up with a network that is recursive. You can have subnets off of subnets off of subnets. Now this is, I believe, the first in the sort of blockchain world. There are many kind of layer 2 networks, but this allows you to create a layer 2, layer 3, layer 4, layer 5 off of that, off of those networks. It's deeply customizable. Like I said, you can actually replace certain elements. You can have your own gas schedules. You could have your own tokens, native tokens for the network. And you could have things like membership rules. So you could have private networks or public networks all built within the same technology. And it's modular and interoperable. So FEM, the Filecoin virtual machine, gives you a virtual machine by which you can then build on top of. So we have the FEVM, the Filecoin Ethereum virtual machine. Well, you could create other virtual machines and just deploy them just to your specific subnet. So subnets allow you to scale both horizontally and vertically. So you can add scalability actually by going along and adding replicas of your network. But you can also scale by going vertically, making the tree deeper. So you can have certain networks that are regional based upon a particular application, for example. So how does IPC work? So IPC, a subnet can spawn new subnets as you go along. So you can create child subnets off of child subnets, and the child subnet checkpoints its status up to the layer above. So it inherits the security parameters of the parent network. So you have the ability for both these kind of like bottom-up writes that come up. So you might have a data center level blockchain in which you're talking about milliseconds of transaction time. And then you might be scaling up to sort of planetary, interplanetary, and then sort of linking on to the main Filecoin blockchain there. So the system architecture. With the system architecture, it's a couple of smart contracts written in Solidity on the network. You have the IPC gateway actor. That is the kind of the index of the different gateways on a network. And it also acts as a mailbox for communication between child networks as well. And then new subnets are spawned by deploying a new subnet actor for each new subnet. And in the workshop that I'm doing later, we can go through this actually hands-on if you want to find out some more about that. And there's a tool we have called IPLC CLI that allows you to run these commands to actually spin up these subnets yourself. So like I said, there's two main actors here, the gateway actor and the subnet actor. And one acts as an index to all of the networks and a mailbox for intercommunication. And the other one actually does things like recording the checkpoints from the subnetwork and deals with any governance from that side of things. So the key characteristics of the network here, we have sidechains that allow you to have staking in the native token of the parent, right? So if you create a subnet off of the Filecoin network, then your subnet would actually have its staking, it's a proof of stake network, done in FIL, the Filecoin token as well. You have data availability because subnet consensus replicates the data amongst the various nodes. And you have things like the security, checkpointing coming from the security of the parent chain as well. I mentioned cross-subnet communication via the mailbox on the actor there. and decentralized scaling as well. So each one of these subnets is its own complete network with its own consensus mechanism. And that consensus mechanism could be altered as well and customized. So I mentioned about hyper-customizability on it. So you can create specific features directly for your network here. So you can have your own specific WASM actors. So you can compile down to WASM based upon any language that compiles down to WASM. You could have your own syscalls to access things like GPUs, randomness functions, hardware, that kind of thing as well. I'm going to skip through some of these because we are very low on time here. So I mentioned about this, it's a truly scalable protocol. Scaling patterns, like I said, you could scale horizontally and create replicas of your function, or you could scale vertically there as well and sort of mimic things like regions. And this is a very common pattern already within, say, Web 2, at which you'll have regional networks as well. So it's something that's familiar there, taking from Web 2 into Web 3. And one of the other really interesting things is you can have ephemeral networks. So you can actually spin up a subnet that lasts a few seconds, as long as a request, as long as a game, for example. So you might have something like, you might have a parent network that represents the long-term information of a game, say the leaderboard over time. But then for each actual individual game, you spin up an ephemeral subnet that is just active and just does a consensus for that one game. And once that game is over, and the information is then posted up to the parent chain, that child chain could be discarded. So you can actually have these ephemeral subnets that are actually run just for the duration of a particular thing. There's a number of examples of people building upon this. So LilyPad, there is a tutorial, I believe, workshop tomorrow on LilyPad. So LilyPad is a mechanism to communicate between blockchains and decentralized compute. So if we're doing things like off-chain AI projects. There's a talk later today, actually. I think it's already happened, actually. I think we've got things out of order here. From Fluence, they're using IPC as well. And there's a project called Spark within Protocol Labs as well that's a sort of a metrics system that is already doing that. We have a testnet called Mycelium, and if you come to the workshop, we'll be playing with that. So it's a reference network that people can use as a layer 2 network to connect to. So come and build with us. There's a QR code that'll take you there to our documentation page. We also have a Discord channel as well. If you go to ipc.space/discord, you'll get to that as well. And like I said, we've got a workshop coming up later. And if you want to find out any more, then come and find me. I'll probably be over there on the booth as well.